Hey everyone, today I'll be showing you how to make a procedurally animated gecko. Start off with a new 2D Unity project, and then next we're going to create a new folder and name it sprites. And in this folder, we're going to want to put in the gecko sprite. I just made this one in Procreate, and it's a PSB file with separate layers for the body and legs. Next, we go open sprite editor, and it'll separate the sprite out into its different parts. Then we go skinning editor, and we're going to want to put bones in it. We go create bone, and this first bone for the head needs to go this way, and then we press escape, and we're going to add bones down the spine. Now, it's important that the bones aren't parented by each other. We just want separate bones for the whole spine. Okay, now that we've got bones along the spine, we're going to do the leg bones. And the leg bones are going to be parented to the bones closest to each leg. So for these legs, they'll be parented to this bone, and for these ones, we'll probably parent them to this bone. So you click and then press here, there, and then you go to the end there, and then press escape. Okay, now that we've added all our bones, we now go to auto geometry. Just press generate for all visible. And that looks pretty good. There's a few parts where we could bring it in a little bit, but just for this tutorial, I'm just going to leave it like this. We go preview pose and just check that it's all working. So that looks good. Okay, so you hit apply and then you can close this. And now we should have the gecko. And mine's obviously very big, so I'm just going to scale it down to 0.1. And then here we have it here. And then bring each of the legs in so they look natural. Now I'm just going to make sure that all of these are in the right order. Closing these ones, we just want to make sure the spine goes the whole way down. Yes, perfect. Okay, so the next thing to do is create a new folder called scripts. We're going to add in a new script called procedural spine. So we start off by making a list for all the spine bones along the gecko, and then an array for the distances of each of these spine bones. So now in our start function, we are going to create a float called previous bone distance, and we are saving that into our bone distances array, going through each of the spine bones, not including the first one, which is of course the head of the gecko. So next what we are going to do is create a function that constrains each of the bones' distance in order to make them act like a chain. This will make it so that if the gecko's head bone moves, the rest of the bones in the body will follow, each while maintaining their distance to the bone in front of them. So to constrain the distance, we are getting the direction of the anchor to the current bone, and then we are going to return the direction multiplied by the distance plus the position of the anchor in order to get the constrained position that the current bone has to stay in. Okay, since we're using a rigged sprite for our gecko, rotating it will cause issues. Each bone's rotation affects the 2D sprite's mesh. To fix this, I'll create a function called constrain rotation. This function takes the current bone and its anchor bone, calculates the angle between them, and returns it as a float. Now let's add these functions to our procedural spine script. In the update method, we'll iterate through the spine bones, not including the head of the gecko, and set their position and rotation using these functions. For each bone, we'll set its position to the vector 3 returned by the constrained distance function, with the bone, its anchor, and the bone distance from our bone distances array. Then we'll set its rotation to quaternion Euler, with 0 on the x and y axis, and the float returned by the constrained rotation function on its z-axis. Okay, so we save that and go back to our project and go to our gecko, and we'll add the procedural spine script to the gecko. So now we've got this list of spine bones, and we just want to lock this and go along, not including these bones, which are the leg bones, and you go over and select all of them and add them to the list. So now when we hit play, we should be able to, if we just select one, we should be able to move our gecko like this. So that looks pretty good. Okay, now it's time to set up the IK for each of the legs. So we're going to go here to our gecko and add a component called IK Manager 2D, and we'll bring that up the top here. And we're going to need to create a solver for each of the legs. So we go plus, and we're going to use a limb solver. We'll name this left bottom, and then we're going to need to make one for right bottom, right top, and left top. Okay, now that we've created these four limb solvers, we're going to need to create targets for them, which are going to go there at the end of each of the legs. So we go in to our legs, get which leg, so this is the right top, and we're going to go create empty, and then we'll call this right top target, and then we're going to need to grab that and move it all the way along to the very end of the gecko's leg, like that. And then we're going to have to do that for each of the legs. Okay, now that we've created targets for each of the limbs and placed them on the end and made sure that they're children of the last bone along the two limb chain, we're going to go into each of the solvers that we made and add the corresponding target into this effector panel. So for the left bottom limb solver, we're going to find the left bottom target, place that in, and press create target. And then we're going to do that for each of them. Okay, now that we've done that, we should be able to move each of the limbs. As you can see, some of the limbs bend the wrong way. We want that limb to be able to bend the same way that this limb can bend. In order to fix that, we go into the right top and we press flip. So now this one should be able to bend that way and not the other way. And then we'll fix that on the bottom so this one and this one bend the same way. So that's almost done setting up the IK. The only thing left to do is we want to grab these ones out of the hierarchy. You want to take their children out. So you select each one of them and then drag them up above the gecko. We're going to need targets for each of the legs to move to. So when the gecko moves forward and the legs move backwards, we're going to want to set them up to a target position. So to do that, we'll go into the root bone of the legs and we'll add in a new empty, and we can call this one left top move target. And then we're going to position this to the left and a little bit higher than the leg, and that is where the leg's going to step to when it needs to step. And then we're going to do the same. We're going to copy that one and change it to right, and we're going to flip it on the Y so that it's on the opposite side. And then we'll do the same for the bottom legs. Okay, so next we're going to create a new script called procedural legs. For our procedural legs class, we'll need these variables: transforms for each leg, transforms for each of the move targets, a float to control the distance from the move target that causes the leg to take a step, a float called can't step offset for alternating leg movements in the gecko walk cycle, 4 lists for the top legs, bottom legs, and their move targets. In the start function, we'll add each leg and its move target to their lists. To get the distance from the leg to its move target, I've created a simple getDistance function. Now we need to create a take-a-step function. In order to create an alternating leg movement, we need to know which leg is the opposite leg to the one that is currently taking a step. To do this, first we'll determine if the leg is a top leg or a bottom leg by checking if it exists in the top legs or bottom legs list. Then, once we know which list to search in, we can find the opposite leg by checking which leg is not the current leg within that list. Finally, we'll find the other leg's move target using the same method. Now, let's check the distance between the other leg and its move target. If it's too close, we'll constrain the current leg's position, preventing it from moving and keeping it at the current distance relative to the gecko's body. If the other leg isn't close to the move target, meaning it hasn't taken a step recently, we'll set the current leg to its move target position. We've created the logic for steps. Now let's control when they happen. We want the gecko to attempt to take a step whenever one of its legs is too far from its move target. To do this, we'll create two functions, step checker and check distance. In the step checker function, we'll use the getDistance function we created earlier to get the distance of each leg to its move target. Then we'll use the checkDistance function to see if any of those distances are greater than the step distance threshold. If so, it'll trigger the gecko to take a step. Finally, we'll add the step checker function into the update and our procedural leg should be ready. Okay, now in order to set up our procedural leg script in the inspector, we're going to put each of these in with their corresponding transform. So with the top left leg, top right leg, bottom left, bottom right, we're going to put in these limb solvers that we took out of the hierarchy here. And then the move targets. Okay, so now our gecko should walk when we drag it. Nice, that looks good. Okay, so the last thing to do is just add a simple script so that it follows the mouse or follows keyboard input. To do this, I'm just going to add one more script to the scripts folder and I'm going to call it Gecko Movement Controller. So for the Gecko Movement Controller, I've just created this simple script that allows you to switch between mouse following and keyboard inputs. And it's pretty simple. You can have a look through it and copy it or write your own. Now we'll just add that script to the gecko and we'll set the rotation speed to something like 255 and the movement speed to maybe 2.2. And we'll have it on mouse follow for now. And we need the moving object, which is going to be the gecko's head. So we'll grab that, which will be bone 1, and drag it in there. So now when we play, the gecko should follow the mouse around. There you go. And of course you can turn mouse follow off and then it walks around using WASD. Thank you. I hope this was helpful and good luck.